This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
Our first speaker is the one and only Tomasz Ducin. Tomasz, the stage is yours.
So thank you very much, Darek, and welcome everyone, and thank you for attending tonight the meetup. So we are going to speak about Angular Query and rxjs Signal Store. It's obviously Signal Store, and how do they both form a symbiotic relationship? So I'm Tomasz, and quickly my background. I've been working since 2007, something like this. I touched Java, I touched PHP, I touched Python, even a little bit of C++ and Perl, but since more than a decade already, I've been focusing on JavaScript and everything around it, mainly on frontend. But my main, let's say, area of interest is architecture, very generally. And what I'm trying to do is basically pick the areas that make sense to kind of transfer from backend to frontend, and I'm kind of researching, analyzing which patterns do make sense to apply and which don't. So yeah, apart from this, what I mainly do is consultancy. So if you have a team that needs any kind of help related to performance, testing, architecture, like you tried micro frontends and it didn't work, whatever, feel free to ping me up. And apart from that, I do trainings on basically lots of JavaScript-related technologies, including design patterns and architecture. So, and yeah, just a small thing. I used to be a, let's say, React-focused developer for quite a few years, though quite recently, something about 1 year-ish ago, I joined the Angular core DevTools team, so I'm proud to contribute to the DevTools themselves. We have a very, let's say, brave plan to release the signals dependency graph visualization within the DevTools tab, components tab within Angular DevTools. Yeah, so this will be my DNA within the DevTools. So yeah, this talk is going to focus mainly about the architectural concerns. So we are not going to dive into the API, what are the methods, what are the functions, I don't know, what are the parameters, etc. This is everything that you can basically study from tutorials or documentation, whatever. I would like to focus on what are the pros, what are the cons of different solutions, how do things fit to each other, what should be the shape, what should be the data flow, what should be the dependencies across different things, so that whatever we build would basically make sense. And if you're interested in architecture and how does that apply to frontend, I would also invite you to take a look at my recent blog post, that is What is Frontend Architecture, where I try to kind of break the myth that directory structure is basically front-end architecture. It's absolutely not. So if you want to kind of dive deeper into what I consider important, here you'll find a kind of 20-ish minutes long read, though we're going to go through these things in some kind of extent today anyway. So the title of this talk is The Symbiotic Relationship between Angular Query and NGRX Signal Store. So what is symbiosis? So one of the definitions that I found is that it's a phenomenon where there is a close coexistence of at least two species of organisms. So we're going to speak about basically two, where there is a benefit on each of the side, or there is a benefit on at least one of the sides, but there is no harm to any of the parties. So there would be at least one party that would benefit. My thesis is that basically these two libraries, the way they are designed, they form this kind of relationship. And one of the biggest, let's say, challenges and problems that I observe when doing consultancy is that picking a wrong tool for a given problem is probably the most common problem that I see, that I observe, and this leads to the code being very difficult to maintain. Actually, not understanding the business problem leads to picking up wrong libraries, and this ends up with the consequence of the code being, well, either too expensive to write, too expensive to maintain, to understand, to test, etc., etc., etc. So, both libraries, as you might know, deal with state management. One of the, let's say, perspectives to take a look at state management is to divide state management into whatever comes from the server. So let's say we need to load the data from the server to the client and basically display it in some way. So we are kind of mirroring the data. And the other, let's say, part is whatever the client is, let's say, the data that the client is creating, the user, through interactions. So whatever the user is typing through the keyboard, whatever the user is trying to, click through the application, whatever. And mainly what our interfaces are using is basically some kind of a combination of the two. So most applications will need the two. And the question is, how do we shape state management to do this effectively, extensively, and so on and so forth. So, quick question. What is NGRX Signal Store? Who of you feel that, more or less you know what this is, generally? Hands up. More or less. Yeah, how many of you feel that, you do know what is it about? Okay, so very more or less, I would say quarter of the people. Okay, so second question, how many people feel that you really understand Angular signals? Well, quite well. Hands up. Yeah, okay, so that would be still 1/4 of the room. So and as you can see, I prefer to make talks or any kind of public performance, whatever, more interactive, so that it's not kind of a lecture, but it would be more like kind of a dialogue, whatever, so that if you want to ask any questions, feel free, we can discuss things here during this talk, so feel free to do it. Okay, so 1/4 understands what signals are about, more or less, and what NGRX Signal Store is about. How about Angular Query? Anybody who feels? If you're familiar with React Query or Vue Query or whatever, you can count that in. Yeah, I was hoping for you, Mateusz. Okay, so so maybe we will start with basically very quickly. Yep.
It probably means that people have not upgraded to Angular 17.
I'll repeat, Sebastian says that probably you're before Angular 17, though even if you are on Angular 17, there is no automatic migration to Signal, so most probably if your application is more than 1 year old, then most probably majority of your state management is still the old way, because nobody would, stop creating new features and exactly. But that's absolutely, understandable. Okay, so just to quickly remind what is the whole idea behind signals. We have 3 fundamental building blocks. So the first one is obviously the signal itself. So how we should think about what a signal is. Let's say the best metaphor, the best mental model. Sorry?
Writable primitive.
Writable primitive, okay, so, this is writable, but what else? What is specific about a signal? For instance, if I have, what is the most important difference between, let's say, a promise and an rxjs observable? Can have different states. Both can have different states. Multiple values, for instance, So this one is going to include basically a single value. So this is basically a wrapper around a value, right? And the API behind signals is purely sync. So that's basically a wrapper around a value, and the second thing is that the API is purely sync. Maybe this will change somewhere in the future, but there is absolutely no, let's say, guarantee, and the core team is basically doing some experiments around whether it would make sense to make it async or not. But actually, those two things, those two kind of design decisions behind signals are, introduce a lot of consequences. The fact that it's synchronous means that whenever you do any kind of HTTP calls or waiting for user interaction, etc., this is never capable of fixing any kind of race conditions. For instance, you need to react something from a signal, like from an input signal from a parent, and then you need to shoot an HTTP GET request as a result, and you didn't receive the response yet, but there is a new value coming from the parent component. So there is basically a race condition. What should we do, right? So with signals, it's not a good idea to try to fix those things because RxJS is already doing that very, very well. So all in all, what are we going to do most of the time is that if we have any kind of interaction with an external system, what we do is we use async APIs like RxJS. Everybody in Angular community should know RxJS more or less. And once we do have the data already, we basically dump it down into a synchronous signal. Because from now on, thanks to the fact that this is synchronous, this is going to be way, way easier. There is like difficult to measure, but I would say it would be 2 orders of magnitude easier to deal with signals compared to RxJS whatsoever. Finally, from technical perspective, a signal is basically a function. So let's say that would be a value, and that's it. So this is a wrapper. Whenever I call the function, I basically get the value. There is always one value, and by the way, this is a wrapper around a value, one value, right? Could there be a situation where there is no value within a signal? It guarantees that it always needs to have a value, so it kind of resembles behavior subject, because it does guarantee that. Okay, so that's basically the primitive. Now the second primitive, let's make it yellow, whatever. And this is the second one. This is a computed. Computed is a pure computation, so this one was writable, as the friend has already mentioned. And computed is something that is going to be built on top of whatever else was used. So this is obviously readable. But apart from that, what changes? Is a computed still a wrapper around a value? Yes. Is it synchronous? Yes. Do we call it the same way? Yes. So that's basically it. Now, the magic, or I would even say the most attractive or the most beautiful, let's say, design decision behind signals is that there is no subscribe, there is no unsubscribe. Like, technically there is, but it's not exposed via the API. Because if, let's say, we have the signal, which is a value, let's say that the value, this is how we define the signal. The value is going to be a signal of 1 to 3, whatever. And what we need to do here, let's say that this would be a square, which is basically a computed, where what we do is a function, and what we return here would be the value squared. Now, here, what we can see is that whenever we want to call SQ, like SQ for square, then we know that we need to walk into the function. So let's say that internals of Angular are aware that, hey, we have entered the code of this computed, and it doesn't really matter whether it's an effect or a computed or a different, let's say, thing built on top of the signal primitive. But we know that we are inside of here. But whenever we want to get the value of the computed, it might happen that this function, if it's not cached, that this function is going to be evaluated. And we are walking into another function that in turn turns out to be another signal. So we know that while calculating a signal, we have entered yet another signal. So what Angular is doing is it's building a dependency graph deep down automatically. So subscription happens automatically and unsubscription also happens automatically. Also, if you put an if statement or a for loop, while loop, whatever you put here, this is going to be live during the runtime. So you don't have to worry about this. Everything is being automatically tracked. This is kind of like, imagine all the rxjs code that you have written where you need to deal with how do you subscribe, how do you unsubscribe, and those stupid endless discussions. Should you unsubscribe or should you not? Should you have the destroy subject or any other ideas that I don't recommend? So here, basically, everything is happening under the hood. Finally, the last piece that we've got is an effect that is going to be, as the name suggests, this is a side effect. So what we can depend on could be basically either a signal or a different computed. Of course, a computed might depend on yet another computed, etc. So the effect is going to be, for instance, a function in which, let's say, this would be a property on a on Angular component class. So the effect would be a function which, in turn, console.log executes whatever is the value of the value signal or of the computed or whatever we've got over here. So how do we know what does, when should we re-execute effect? Because initially we don't know whether this effect has run. So just to make sure that this thing has been executed, whatever it is, we need to run it initially. And since we run it initially, we know that we are inside of a reactive node. In effect, all of these are reactive nodes. So we need to walk to see what are their values. So the dependency graph is going to be updated, including the effect itself. So it's basically kind of a perpetuum mobile, right? That it basically keeps on running and running and running, and we don't need to do anything with it. So basically, there are lots of different APIs in Angular, like inputs, view child, view children, content child, content children, model input, and so on and so forth. But they're basically based on Signal itself, either writable or read-only. Read-only, of course, not readable. But these are just small details. So what is important here, everybody? We want to use signals within modern Angular because it gives us what is called fine-grained change detection. And that basically means that whenever our template is going to include, let's say, this is going to be a div, obviously, because why something else? Whenever we put any way of consuming a signal value, the Angular's template is going to be kind of similar to effect, although this has nothing to do with side effects, or not very much. But the thing is, whenever this value changes, I will need to update this template, or even only this text node. So what we can expect in upcoming versions of Angular is that this component would update its template only when its dependencies notify that it should rerun this template. What we can expect in future versions of Angular is that not the whole template would be updated, but only this part, right? The text node, or a span, or a div, or whatever. Because why updating the whole template, right? Of course, it requires way more work than this is introduced already, but this is something that we can imagine. Now, imagine the whole chain detection algorithm within Angular so that whenever there is an async, let's say, notification, async event, async API kicking in, ngZone is notifying let's say, the root of the application to traverse the whole tree of all components. It is going to reevaluate only the components that are marked dirty. But still, if you have a few thousand components, you still need to pay the CPU for traversing the tree, even if nothing is dirty or very few things are dirty, right? And why doing this mark dirty, mark for check, detect changes? Why overcomplicating all those things? Why just not let the framework evaluate everything automatically? So the whole point is, from now on, you will want to have as much of your state within signals. And you can create a lot basing on signals and compute it. Generally, fx is something that you use only in very special cases, so most of the time you're going to use lots of signals and lots of computes. From the trainings that I've been doing already in Angular, I found out that what is kind of difficult for people is finding out what is the source and what is the derivative. Even if we design, let's say, let's design pagination. It's not immediately obvious for people what should be a signal, what should be a computed. So if you find this concept rather simple and you more or less know what is the state and what is a derivation, like something built on top of something else, then you will feel in signals like home. Yeah, so where could we put a signal or a computed? On a component class. Where else? On a service property. Where else? Anywhere. That's a very good answer. Anywhere. Anywhere. Especially if you create POJOs, plain old JavaScript objects, or POJOs, TypeScript objects, whatever. Yeah, anywhere. And the thing is, dear everybody, how do you think the complexity in your UI logic, in your domain logic, etc., how would that scale? So the thing is, we have no structure here. Not yet. So these are just primitives. This is a primitive built-in. This is also a primitive built-in. So the whole point of what NGRX Signal Store is giving us is that it will give us a very, very, very simple API that is going to basically group these things. So we have the with state, which basically introduces whatever is the initial state. So this is the one over here. Now, we have with computed. We're not going to, dive deep into the API, etc., but still, we have some state, which is an object. Now, we get the state that we already have, and we destructure it. So here we have a property called books, property called filter, whatever that is, and we create one computed, which is what? A native Angular computed. Simple as this. Or another one, which is basically sorted books, where we do some filter and doing some sorting, to sort it, which is the immutable version of old dirty sort. Anyway, this is a computed, this is a computed. So, and we have the with methods, which what with methods is doing is that this is basically a function, update query. So this is basically a string, whatever that is, and the patch state. So this is a slight, let's say, wrapper. What patch state is doing is it's taking whatever the state was and basically applying a patch, kind of similar like we do with Redux, though there are no actions here, no action object. Basically, if I have multiple slices, patch one slice, and the other slices are basically untouched. So that's basically it. So this patch state, what this function is doing is that we provide only the slice that is patched, and the rest is basically like just pass it through. So what we would have with Angular signals natively is that we would basically create signals, we would create manual computeds, and we would also create some methods that would directly update the value of a signal through the set or the update function. So how do you think, what is the whole point of using this library? This is, I would say, 80% of what this library gives us. Like, there is not very much more. What's the point? What we do, and by the way, what we do here, this returns a service that we directly inject. So no magic. This is totally no magic. What's the point of using it, since this doesn't give us much, right? Apart from what we already have. Okay, so the question is whether having more abstractions is useful or actually counterproductive. Because the fact that I have, everybody can create lots of abstractions, especially useless ones. You know what I mean? Like, the fact that we create an abstraction doesn't necessarily make it easier to work with the code, because there is one more concept that you need to understand. You need to figure out, like, what are the good, practices with it? What are the bad practices with it? So yes, there is an kind of an abstraction, but what is the point? Everybody, this is the simplest way to organize stuff in bigger things. As you can see, this is a function call that we can that we can basically reuse. This is yet another function call that we can maybe not reuse, sorry, let's revert it, that we can encapsulate, not reuse. So yeah, reuse only when you see that something is used at least a few times before you basically make something dry, etc. But this is basically a way where we can create a set of signals and computers and methods that work together. So all in all, whether you're using native signals like the built-ins or this one, there is no paradigm shift, not at all. And I hope that after this presentation, you will feel like this is the same way like working with signals and NGRX Signal Store. So there is basically no semantic difference. This only organizes, lots of various signals into a, let's say, cohesive set. Cohesion is basically whenever we have the fields, the properties, and the data that are used within functions together. So high cohesion is basically when we have an object and we would like to split it into smaller pieces, but it turns out that lots of methods are using lots of those properties. So it's difficult to split it into pieces, because if we wanted to tear apart, it turns out that there are lots of functions who would basically break because they need all of them. So if something is difficult to tear apart, like in physics, this is called high cohesion. And if we have loose model, like, very anemic model, what is called, then we have low cohesion is basically, it's a model that is not very useful. So all in all, basically, what is this thing responsible for? The client state, first and foremost. So how we could, and of course, in all applications, we need to do some calls to the backend. So we need to include some server state data. And this is where this funny inject thing comes into play. Now, how many of you have been using the function-based inject call? Hands up. Okay, so if you have constructor injection, like, private, the name, and the class, so this is basically the same thing, working in a very similar way, but this is basically just a function call. So this is the token that I want to inject. This works only in the constructor phase or a field initializer, a factory function that is basically an item of a provider setup, or a custom function called run in injection context. But it's basically a different API, but it's the same dependency injection, just a function, not constructor injection. So to everybody, when is this line being executed? When? The time. When we actually update something, or when we run a compute it? Probably not. When is this line being executed? As you can see, there is quite a bit of functional composition, right? So the most outer function is basically the signal store, so the declaration. So this is how we declare a thing. This is not yet the instance, right? Because this is a service definition, not yet the service instance, right? So this is the declaration. So we have not created it yet, right? So basically what Signal Store is doing is it's fetching all these things, and basically it's a middleware, or like a chain of responsibility middleware pattern, something like this. So take this thing, take the result from it, pass it into with computed, which is going to attach some things, basically pass it to the next one, so attach some more things, and basically pass through and pass through and pass through, and this is how we compose the things. So all in all, if you have, let's say, generic pagination, generic filtering, generic sorting, you can basically reuse the thing, just passing certain parameters, etc. So what this thing is doing is just declaring what the store is, not yet creating the instance. Now, when you would have a component that actually wants to have the store injected, this is when the class, the instance of this class gets created, and this is the moment when this thing is run. So when the object is created. So when dependency injection is available, right? So all in all, this is one of the, let's say, trickiest or one of the most beautiful pieces within NGRX Signal Store. How do you think? How much effort did NGRX Signal Store, Marko Stanimirovic, how much effort did he need to put to support this? Nothing. Because he knows, or he knew, that this line is being executed during the initialization of an object. So this is basically available. So one day I wanted to figure out how did he implement it, and I didn't find any piece, right? Of course, I asked him whether my reasoning is correct, and he confirmed that. So all in all, you could basically put how many things you want here. Now, what is the whole point there, everybody? You can inject anything that you need here. So we have the client state. Now we need to combine it, compose it with the server state. And this is where Angular Query kicks in, right? So let's get back to our slides for just a while. And this is where Angular Query kicks in. So I'm not going to, yet again, go through the API, which is maybe not very simple at this point, but in very, very short, if this is, let's say, our application, whatever that is, let's say that would be our component or whatever we need, then the thing that we have is that there is a query client, something that we are going to interact with. So the function that we're going to use is an inject query, and that basically means that there is some resource on the server that this component requires. So basically, I need a list of books, I need a list of payments, I need a list of something, or not even a list. I need a single object, no matter what it is. I just need something from the server. And I don't care. I don't care about running the HTTP. I don't care about caching. I don't care about canceling. I don't care about, let's say, running the timers to configure, like, when would I consider this data to be out of date, that I would need to rerun it, etc. Angular Query is doing everything for us, right? So there is one concept that you need to learn. It's basically called a query. So what I would suggest you to think in terms of Angular Query is that a query is basically a dependency, a state dependency. I need to have some data from the server. So I have a dependency on server data, right? So let's just quickly draw it. Yeah, it's effective usage of the cursor is always useful. So this is where we've got the server. So for this reason, I'm going to draw it in red. And there is basically a line that we are going outside from the client to the server world. So now when there is a component that requires some data, this component is going to include some code that basically says inject query, blah, blah, blah. So just define what the query is, right? So yeah, the component requires the inject query. Inject query is basically a very tiny facade over the query client. So if I want to have a inject query of, let's say, books, whatever the books are, query client is going to figure out, do I have this data? If I don't have that data, then what I'm going to do is basically fetch it and store it here locally within a cache. So this is basically query cache. We don't have to work with it directly because this is basically handled for us. And query client is basically a manager that is going to work on the query cache directly. Now, if there is a second component, that's the whole point. If there is a second component which requires to have the very same data, it basically runs inject query. And here, as you can imagine, query client already knows whether it does have the data or not, whether it's kind of fresh, up-to-date, or maybe it's out of date, so we would need to rerun it, etc., etc. Now, query client is going to, first and foremost, well, make the data shared. This is going to invalidate the cache if enough time has passed. It's also going to mark the data as stale. For instance, the thing is, if I'm moving into one of the, let's say, tabs, and I see a list of payments, now I walk into another tab in my application, just to see something else, and I walk back to the tab. Now, normally, your component would get destroyed, and you would have no data, normally. Now, most probably, you want to reload the data, right? But what would be better for the UX? Should the user basically see nothing, just a spinner, and wait 2 or 3 seconds, whatever, or maybe let the user see what was there, but also automatically rerun the query, and everything basically happens automatically. I would need a few hours to say about all the goodness that basically Angular Query gives us. There is a shitload of various features and improvement that it basically gives us. So to be honest, like this is something that has taken React ecosystem by storm. And if you're not using, for instance, React Query for managing server data only, not the client data, server data, then you're probably over-engineering the stuff. Angular Query is basically a straightforward port. This is exactly the same idea. If you learn React Query, then you know Angular Query, and vice versa, etc., etc. So basically, that's the whole thing. Now, how does this work, this inject query, from the technical perspective? What we have over here, this is Tanstack, no, not React. Please give me Angular, not version 4, version 5. Yep. So, yeah, inject query. This is the way that we are going to actually, we need to tell Angular Query how to actually access the data. So we do have a service that does do HTTP, let's say, via rxjs. But we are not responsible for storing the data. We don't need to decide whether this is a service per component or a global service, or when do we clear the data from the service, etc. This only does HTTP and returns a stream. That's basically all it does. And now the thing is, if I want to fetch some data, whether this is books, to-dos, whatever, I might want to load all all books, or only the first page of books, or only the books that are written by Paulo Coelho, or the books that start with letter A, or whatever. So whenever you run HTTP GET requests, there might be various parameters, lots of parameters. The whole point is that all these parameters should be reflected in the query key. This is the identity of the resource that you fetch. So whenever you want to go from the first page of the books to the second page of the books, you need to have this page ID somewhere here, so that if you have a different key, this is basically a different query, essentially. It's the factory for doing the request is the same, because this is the same, let's say, REST endpoint, but this is a different data set. And this is all you do. Now, you don't need to worry about sharing. You don't need to worry about destroying the things. This is very, very highly configurable, but that's basically it. Yeah, so what does query return? What would you expect if you get some data via HTTP? What would you expect that you get here? Sorry? Yeah, what data would you, yeah, data, type, shape, schema, whatever we call it. The data itself, the response, what else? Loading state, what else? Error, so at least these three. And what is important? If I do have the data, I don't have the error, right? If I do have the error, I don't have the data and it's not loading, etc., etc., etc. And I don't want to walk into state machines. But we know that only some of these, let's say, combinations do make sense, and all other combinations make totally no sense. So instead of reinventing state machines over and over and over again, they're already there. So all in all, what you would need to do in the template, I'm not sure if the template is going to be here. Not sure. But anyway, what we would need to make sure over here is that only if the data is here, or we are not inside the loading state, we are not inside the error state, etc. Only then TypeScript would allow us to actually iterate over the collection, which is kind of something that all of us should do all the time anyway. So this is basically baked in because why not? Because this is the right way to do it. So there would be never a situation where you have an error, but you still try to run a for loop or whatever else. So that's the thing. Now, any questions when it comes to NGRX Signal Store or Angular Query before we combine them together? Does it make sense, basically? This is an object, yes, which exposes some methods. But basically, the first thing that you should, this is a super, super simplified example, just not to scare people away. But what you should do is basically to check in which of the 3 most fundamental states you are in. Of course, there are more. As far as I remember, there are 6 states, but basically, logically, they fall down into loading error and data success. For instance, you have fetching, but you also have refetching and initial fetch, etc. So sometimes you do care whether this is the initial fetch or any of the other fetches, or whether you, let's say, have nothing and you are waiting for the result, or whether you do already have some old data, but you do reload them. Sometimes you need to differentiate these things, sometimes you don't, but essentially there are 3 states. What you should do is basically first an if, and then when you are inside an if or inside an else, then you basically either display the load or display the error and display the, consume the data.
Because usually with rxjs, you're doing async, right? Async file.
Yes.
And what is the difference? Can you tell us?
Yes, of course. So, yeah. So, right. So we will get back to state machines just for a while. The whole point of state machines, of basically displaying the data in the UI, is that if this is, let's say, loading, this is the data retrieval, and this is the error. Of course, there are allowed transitions between the states. There are unallowed transitions. For instance, from loading, we can walk into data and we can reload. From loading, we can walk into error, and from error, you can also reload. But this one doesn't exist. For instance, there is no such transition, but never mind. The thing is, you need to, a component could have 3 different states, but you don't know in which you're in. And the whole point is that you make this declarative so that in whatever state you're in, you should display this component correctly. So hence the if statement. So this is basically the most, let's say, appropriate model for the most, let's say, standard use case of data fetching, right? So your component is basically going to make a couple of if statements or a switch statement, whatever you need. So that's basically what you have over here, sorry. You're just doing an if statement over query dot is loading, query dot is fetching, query dot is error, query dot state, or state is not sure what the name was. So that's basically all you do inside your component. So you don't need to do any stuff that is related to subscribe or unsubscribe, because Angular Query is doing this for you. And you don't need to do any kind of twisted things like, you load the data and you have a pipe where you have the tap operator, which is going to snapshot is loading into a Boolean property, or snapshot the error property. No shit like this. Basically, that's all you get.
Signal, right? This is
Yes. Yes. This is future proof, because that's the point. Exactly. Like for this, yeah. You can see this is a signal from here. You can see this is a signal over here. Yeah, sorry for me not being explicit. Yes, this is a signal. Yeah, whenever you have a function within your template, 99% this is a signal, because that's the whole point, unless event listeners. Yeah, so yeah. So the point is, dear everybody, that query client is basically a singleton, because why would we need any more than basically one singleton? Now, the data is being shared. Now, this could be a good thing, or this could be a bad thing. Now, if you have, it depends on the size of your team, how many modules or subdomains, bounded context, whatever, how many of those you have, that's one topic. And whether you have a monolithic application or a distributed micro frontend, this is yet another thing. But still, if a component or a view or a tab, whatever it is, if it needs some data from a certain endpoint, and two different components, let's say, being created by two different teams, if they shoot to the very same endpoint, they're going to get the very same data, right? So do we have any problem here? No. So even if I have a distributed system, or let's say a monolith, so like a big application being created and maintained by multiple teams, autonomous teams, etc., is this a problem that we are caching it? No. What they care a lot is basically inject query. This is absolutely critical, what they care. But if they create a different key, then there is basically a separate slot for the data, whatever, right? But if it turns out that the keys are the same, like, why not reusing the data? Because the server is not going to return something different, right? Because fuck you, that's why. No, it's not going to do that. So yeah, right. So let's, do we have any further questions about this? No? So how does these two things fit? Now, this is an architectural diagram of a front-end web application. Now, let's make it slightly more precise. So, what are the areas that we're interested in here on the front end? So, let's make it slightly more interesting. So, there is a user, there is a backend somewhere deep. So, what are the areas of responsibility here on the front end? So, everybody, we want to, among others, we want to handle in terms of state management, the client state and the server state. What I want us to figure out is what should be the dependencies here and what should be the relations between them. So what we have over here is basically the UI. So what the user can see, what the user can click, what the user can type, and all different ways of interacting, right? And how does that affect the communication with the backend? How does this affect state management? So we're going to have the, let me just take the rectangle. This is one of the last pieces of this presentation. So let's say that there is the server state. This one, I'm just going to make this, maybe like this, slightly smaller server state. And this is the client state. So yeah, what should be the relation between them? Most often, what the user is doing is they do work with, like, they do click something, create something, but not just out of the blue, but on top of something that comes from the server. Exactly. So basically, this is the, and yeah, again, like, drawing the direction of the arrow can be very tricky because it depends what does the arrow exactly means. So there is a very nice, let's say, concept that we can borrow from domain-driven design, and that is defining who is the logical upstream and who is the logical downstream. Now, don't get fooled. This is not the same as upstream in RxJS and downstream in RxJS, because RxJS upstreams and downstream define the direction of the data flow. Like the data flows from the top to the bottom. So here, the upstream is basically who provides the API. This is the one that provides the API, no matter whether it's a query, a event, or a command. Whatever that is, this is the provider of the API, and this is somebody that consumes it. You could think of it as a provider-consumer, this relation. So who is the upstream, who provides the API? Who is the downstream, who uses the API? The server is the one that provides the API, right? And this one is the downstream because it will do something on top of this state over here. Now you can imagine that whatever the data we're going to fetch from here is going to be exposed as what? The signal or a computed? Computed, yeah, because this is reactive, like signals are reactive, but there should be no way for us to directly modify it. We can modify something locally via the client state, and this is basically just a mirror, like eventually consistent mirror of the data from the server, right? So, yep, this is the direction. So, yeah, what we're going to do here, we're not sending any commands, we're not changing it, we're not sending any events from here over here. This is basically a query relation, right? So, but there is no problem with a query because everything exists in the same RAM. So, server state is, everybody, Angular query. Simple as this. And what we've got over here, bless you, is NGRX Signal Store. NGRX Signal Store. Yep. And what is basically the logic that we can define? What could the logic define? Let's define the logic by yet another rectangle. So that would be logic. And let's maybe make it slightly more readable and make it blue and make it smaller. So this is going to be our logic over here. I'll probably just, damn it. Draw it like this, logic. Yeah, so what our logic to everybody could use. What does the logic has access to? The client state, but also the server state. Why not? Right? So the logic could also access this one. Like, of course, this depends on how do we want to, whether we want to encapsulate something or not. But basically, there is, as you can see, one-way data flow. There are no cycles, nothing that we should be, afraid of. So, all in all, as you can see, these are two different libraries that do totally different things. What is also worth mentioning, NGRX Signal Store could be bound to whatever services you've got, even just pure TypeScript classes. Really, whatever this is. But I believe it's really, really great to not to learn any new concepts that you already have in Angular, just group them together to make your store cohesive, right? So that the methods that you have and the computeds and the signals, they basically create a one small or big feature, but that's basically, coupled together so that it provides some kind of a feature. And now this is highly specialized in basically handling your local data. This is your external data. Combining them together gives you the best of both worlds. So each of them does a very limited, let's say, has a very limited responsibility, but they're very, very good in handling this type of logic. So, yeah, that's basically the whole diagram that you can apply to all of your components. Now, if we discussed some higher, yeah, question? Yep, Sebastian?
Is there any way to automatically update the server state via some mechanism when there is new data available on the backend side?
Okay, so it falls down to the nature of HTTP and the protocol that you're using underneath. So if you're using HTTP, then all that you can do is like re-execute, re-get, re-query, etc. You could be using any kind of server-sent events or WebSockets, but this library is focusing mainly, first and foremost, on HTTP, only because this is the most frequent usage. So basically, this is trying to meet you where you are, most probably where you are. So this is not specialized in neither of WebSocket or WebSocket-ish solutions. So yeah, but the problem with a query, whatever query you have, is that all queries, all HTTP gets are always eventually consistent. That means that whenever I pull the data from the server, pessimistically, it's already outdated. Pessimistically, always outdated. It could be already different at the source. How can I know when I receive the response that nothing changed there? How can I make sure? I cannot. That's the point, right? So, yep.
Yeah, because I think I get the point from Sebastian that what
Yes.
We are going back to the history of your payment.
Yes.
And you want
So
to
what
refresh state, right?
there is, yes, there is a,
They maybe also want to import
yes, yes.
many times, right?
There are hundreds of very, let's say, well thought out features that I haven't mentioned. So what you do have in React Query and Angular Query, and this is something that you would do rather sooner or later, is that apart from queries, you also have something that is called a mutation. So mutation is basically that you change something which is HTTP post, put, delete, patch, etc. And now, if you, let's say, grab a book, then destroying a different book doesn't invalidate this book, right? But if you grabbed a list of books and you change anything there, it could. So what you do basically is that you're doing queries, and aside of that, you're doing mutations, and a mutation might most probably alter your query keys by destroying them, invalidating them, refetching them, prefetching them, etc., etc. So I just didn't want to introduce this concept, but basically there is a query mutation query relationship, which is something that you should have anyway. Now imagine you would have to do it in all applications whatsoever, but this basically gives you a pattern to do it. So yes, absolutely. And could you repeat, please?
The same like Apollo client in graph. You can there is an option from queries like network only. You can and that's why execute every time like fresh case.
Absolutely, absolutely. Like you can configure whatever you need, but what is important is that whenever we run a mutation, what you do on a mutation success is you alter the query keys, exact keys, a certain key or a key range or a bigger set of keys, because like you don't alter the cache as a whole, but what you care about is the identity of your resource, which basically falls down. Basically, this is a great dictionary, right? So here you have the query key, and here you have the result, whatever this is. So what you do basically is that you alter the keys. Right. So, did I manage to answer this question? Yep. By the way, you can ask me whatever you want after all the presentations. Yeah. So, all in all, that's basically as simple as, I'm not going to say what, but that's basically what you do. And you don't need to create a store that is going to be global and very, very big and complex, etc., because you might necessarily not want to introduce a, let's say, single source of truth or single source of synchronization across different teams, which could kick your ass if you're working in a multi-team environment, for instance. So this is, by design, this is distributed. Like this is not meant to be used as a single thing. So there is no such thing as a slice within a single store. What you're going to do instead is basically that you're going to have, you're going to basically have multiple specific stores, and that's basically it. Like, why would you have something that is centralized if it doesn't give you any kind of benefit? Now, if you're used to using the classical NGRX and you love centralized things, now don't worry. In this case, like, the point is, if you want teams to be in a multi-team environment, if you want to be autonomous or open yourself to, let's say, split your applications into smaller ones, whatever, if you introduce something that is centralized by design, you're going to cry at some point in time. Because how could you break something that is centralized? Now, if you want to distribute your application and you would like to leave the classical NGRX, this is the worst possible scenario, because you're going to introduce what is called a shared kernel. So in an environment when teams want to be autonomous, you put a single piece of synchronization that everybody and nobody is responsible for. This is a perfect recipe for a catastrophe. So you don't want this. Now, like, what is the benefit of creating one gigantic store if you can have basically lots of smaller stores which do exact the thing in this component? Now, if you want to share data, because you might want to share data, you get this out of the box on a different level. Like, why would you reuse client state across different places in the application? Hint, most probably you don't want that, right? So going back to the design questions. So upstream versus downstream, so this is something that we have discussed. So there is basically one direction of the data flow. Now, we don't need to worry about commands and events because we only care about the queries. This is the only thing that is going on here. Now, what is shared and, shared and global actually means the same thing, sorry for this. What is shared within this approach, dear everybody? What is being shared, potentially? The server state, yeah? But the client state is not being shared. Now, again, distributed is basically whatever your client state is, and you have multiple stores. So if you split your application and somebody would say, oh, we don't want NGRX Signal Store in the future, go on with it. Like, why not? If you want to opt out from Angular query, like, do whatever you don't need. Like, there is no single point of synchronization across teams. So you can do it absolutely well. So micro frontends and monoliths. As you can imagine, there is nothing that would stand in our way to implement a monolith, like modular monolith. So an application that is big enough that multiple teams are working on it, but the teams want to be autonomous, right? Again, if we have anything that is being shared across different teams, that it could lead to a problem, because if something is shared, then there is a problem of ownership. If you want to update it, change it, remove it, do whatever it takes, then who is responsible for it if something is being shared? That's the problem. So a team is autonomous if they control everything from the bottom to the very top. Now, if something is shared, if either something is shared or the team is autonomous, right? It's either or. Now, could we make a, dear everybody, modular application? Absolutely, yes. So technically, the query client is being shared, but you can basically use different query keys and that's it. So on your logical level, this is separate. This is technically also separate. Now, if we want to implement micro frontends, so an architecture where we want autonomous teams to deliver and take care of our application on their own, can we do it? Basically, if I have a module that relies on NGRX Signal Store and another module which have another signal stores, so they're basically totally different code bases being totally independent on each other, so the split is automatic, right? So technically, the keys could be separate, but the library is the same, so this could be a problem, right? For instance, you would like to update Angular query from version 1 to version 2. This is a potential place for a problem. What could we do? Each micro frontend, if you want to be technically separate as well, is basically installing a separate setup for separate versions, and that's it. What you can do, not initially, just not to increase your bundle size, but do at the very first place where somebody needs to update anything, and then you basically introduce separate query clients, whatever. That's it. So if they're technically separate, this means they have separate query clients, separate query caches, then they are separate. But this is... if this is a centralized thing, yes. Yes. Yes, but if you walk into micro frontends and you want to be separate, then you are separate by design and you are technically also separate. So sooner or later you will want this. Yes. Yes. Yes, and in a distributed application, most often you want to share nothing. Yeah, sharing is not caring in a distributed environment. Yeah, so I hope that I was able to kind of convince you that you don't even know what your target architecture is going to be. By the way, the architecture is going to evolve as long as the project is alive, so this will change. And what convinces me to go with this approach is first, it's simple as, and this can evolve into any direction that you want. So even though tomorrow we are going to know more about our application than we do today, because that's basically our reality. But we can adapt this very easily whatever the business environment is, whatever the business requirements are, etc. So yeah, that would be for everybody. Thank you very much.